Ionic substances are held together by ionic bonds, the electrostatic attraction between cations and anions. And the reactions that can produce ionic compounds from atoms or molecules or ions involve electron transfers. So we'll look at the example of sodium and chlorine making sodium chloride. So sodium and chlorine are both neutral atoms. Sodium chloride is an ionic compound, which means it's made up of a sodium cation and a chloride anion. Sodium atoms have a single valence electron, and chlorine atoms have 7 valence electrons, so their Lewis structures can be written as follows. When these two atoms interact, the sodium is going to give up its electron entirely to become positive, and the chlorine is going to take the electron to get 8 electrons and become negative. So sodium's electron is transferred to the chlorine. And because there are now 2 ions, one positive and one negative, there will be an electrostatic attraction holding the two together. And this kind of process is typical for ionic compounds, where one of the species transfers its electrons to the other, resulting in positive and negative ions. And in bulk systems, this typically shows up as very large repeating arrays or lattices of alternating positive and negative ions, something like this. In this example, we have a 3-dimensional lattice of sodium chloride, and the green balls represent the chloride ions, while the purple balls represent the sodium ions. Now, I've told you that, but based on your knowledge of ion sizes, sodium ions being smaller and chloride ions being bigger, hopefully you could have worked that out for yourself. And one interesting thing about these extended lattices is that each sodium ion or chloride ion is going to be surrounded by not just one of the opposite charged ions, but by many of the oppositely charged ions. And the resulting electrostatic attractions tend to be very strong. And these very strong attractions are responsible for some of the properties that we associate with ionic compounds. Things like brittleness. To break an ionic compound means breaking this very stable lattice structure, and very high melting points. All of the different attractions holding these ions together are very strong, so it takes a lot of energy, a very high temperature, to force them to melt or separate.